right, and we're going right to our next talk, which is Job Snyders from NTT, who's going to tell us about selective blackholing.
Good morning, NANOG. I want to talk to you about a concept I call selective blackholing. In essence, it's a very cheap way to control the damage DDoS attacks put on your network. Blah, blah, blah. We're going to cover selective blackholing from two sides: how you can implement it as an operator and offer it to your customers, or how, as a customer, you can use this routing policy concept. And I'll show some graphs on what the actual impact is when you use selective blackholing. Selective blackholing is that you instruct your service provider to discard packets, but only when certain conditions are met. For instance, when the prefix propagates outside a specific geographic region. And this concept is important because most DDoS attacks are focused on the content side of things. And most prefixes or content servers have a geographical relevance that diminishes the further the eyeball is away from the content source. In other words, I worded it wrong here, but a Texas gun web shop owner probably does not care a lot about Dutch citizens when he's under a DDoS attack. He cares about people that are close by his web shop, geographically seen, US citizens. Sorry. All right. Can you still hear me? What's wrong with classic blackholing is that it's an all or nothing proposition. You have an IP address that generates revenue because there's a web shop on it or something. And the moment it's under attack and you put a black hole on it, nobody can reach it. The illegitimate users or abusers of the service cannot reach it, but legitimate users that are willing to spend some money can also not use it. So all or nothing, I don't think things should be as black and white as they are with classic blackholing. So then we introduced the concept of scoping. As I said, a Texas web shop owner cares about American visitors, less so about Dutch. There are two things we should keep in mind with selective blackholing. If you do selective blackholing, you will still receive a portion of the DDoS traffic, because DDoS traffic that originates within the same region as where you whitelisted the prefix will still get through. And the other part of it is it's a very cheap method, but it still causes unreachability. It's not like scrubbing. It's a different thing. Let's assess the effects of selective blackholing. I used the RIPE Atlas system, all those tiny probes spread around the world where you can run measurements. I did an implementation of selective blackholing in a certain network, and I made it so that outside a radius of 1,000 kilometers, packets would be discarded, but inside the radius of 1,000 kilometers, traffic would just forward as usual. And you can see that, indeed, all the American probes could no longer reach the IP address which was originated in Amsterdam, and they were outside a 1,000-kilometer scope. But within Europe, within a 1,000-kilometer radius, it worked roughly. You can also set a scope to something different, like discard packets outside the country of origination, but keep forwarding traffic inside the country of origination. And you see that the amount of Atlas probes that could reach the IP address now is drastically smaller, as the Netherlands is a really tiny country. You do see a few weird red spots in the lower right, and that's the disease of the routing system I call remote peering, because these guys, they connect over gigantic distances and from a hot potato perspective, it appears as if they are at the Amsterdam Internet Exchange, but they're far away. And if we zoom in further, we can see that if you slap on communities that set it to discard outside the country of origination, then inside the country of origination, reachability is perfect. And this will work for most networks that purchase transit and do some peering in all the countries where they operate. Now let's dive into the difficult aspect. How do you set this up as a carrier to provide this to your customer? You start by defining some communities. We'll use AS15562, my personal AS, as an example throughout this presentation. And one of the neat tricks about selective blackholing is that you can offer the same set of communities regardless of the location where you interconnect with your customer. Because we say this country or this continent is the place of origin. It's where the customer connects with you, and they can use these communities on all interconnections regardless of where they connect. The first thing you need to do is you need to assign some integers to your routers. We define a continent ID. In this case, the Asian region is 3, America is 1, and Europe is 2. I prefer using the ISO standard for assigning country-based integers to routers. And then a city ID or a metro or a market specifier, something that is smaller than country. It doesn't really matter which numbers you choose, but be sure to make them consistent across your network. And it's useful to put in the database the GPS coordinates of your devices so we can calculate for the 1,000 and 2,500 kilometer radius communities. On each router, you put these integers that you assign in your database in a referenceable community. So in this case, this is the router in New York. We defined that the United States is 840, and you can see IP community list this country, and it matches the 840, which is US. And we do this for all devices in our network. Please realize the only thing that differs from device to device is this community mapping. All other policy is a copy-paste that is the same between all devices. And before we dive into the policy maps, I want you to remember this image. On the far right side, we have the customer. The customer propagates a prefix to us with a special selective blackholing community. And when the prefix propagates throughout the network, at each step, a verification is done. Is the router inside the region or outside the region? And depending on that status, it will either continue forwarding traffic or start to discard traffic. So in this example, the customer tags it to, it's really small, to discard outside Europe. And the prefix propagates throughout these routers over IBGP sessions. And when it meets a router in the United States, it's verified whether the communities that were associated with the prefix when the customer inserted it in your network in Europe are met in terms of locality. And in this case, they are not. So discarding starts happening. One of the most important aspects of selective blackholing is the IBGP inbound policy. And in this case, this is a brocade example. This is to prove that if you can make it work on a brocade, you can make it work on anything. This policy is applied on inbound. So when prefixes or updates reach the router over IBGP sessions, it will, that's the place to validate whether selective blackhauling is applicable or not. The first stanza permits 100. It will match a classic 666 discard community. If the prefix has this community associated with it, start blackhauling. That's simple. We're doing selective blackhauling, so we're not going to match on stanza 100. Stanza 200, it matches with 660, 662, 663, 664. These are the selective black hole communities we defined earlier as the ones that we want to expose to customers. If selective blackholing is applicable, we will jump towards the place in the policy where we will match whether we are inside a region or outside a region. In iOS and Brocade, you do continue 1100 to jump over to the test and branch. If the prefix did not carry black hole communities, it matches with permit 1000, and since that's an empty permit, it will accept anything, which is usually what you want for IBGP. At stanza 1100, where we came from when we made the jump in stanza 200, we do a match whether we are inside the country or not. So if the prefix matches with the country, the metro, or the continent, it means that the device which has this policy is still inside the region where we did not want to discard traffic. So it will just accept the BGP update, install it in its forwarding path unaltered, and continue forwarding traffic. However, if we did not match with 1100, this means we're outside the region, and that means we have to start blackholing. So then we set the next hop to 10001, which is a discard route. On the customer side of things, the routing policy that receives updates coming from your customers, we have to do a few tests before we can admit a selective black hole route or not. Stanza 200, the first one in red, is just classic blackholing. If the customer is allowed to announce the prefix, then they're allowed to also black hole the prefix, and this is, most of you guys probably have this implemented. At stanza 300, we match with the scoped actions or selective black holes, and we match whether the customer is allowed to announce the prefix. If this is the case, we will make a jump and continue to a separate part of the policy and not treat it as a regular prefix. So we jump to 600. Stanza, the third part in green, that's just your regular stanza to admit customer prefixes, assign them a local preference that is higher than peering. That's business as usual. If it did not match with any of these stanzas, then the customer is not allowed to announce the prefix, and then we discard the prefix. This assumes you update the prefix list with something like IRR filtering. At stanza 600, where we jumped from when we matched that there was a scoped action, we figure out what the intended action is the customer wants the service provider to perform. And depending on that, we will add some communities. If the customer wanted to discard outside a 1,000-kilometer radius of the router, we add a specific community, in this case 65123:129, and this will help the other routers in the network that match on IBGP to figure out whether they are inside the scope or outside the scope. And for each of the functions we defined, outside 1,000, 2,500, outside this continent, outside this country, we add special communities to match on locality. And this is the reason why this concept works. At each step in the propagation throughout the service provider's network, we can verify, are we inside this geographic region or outside this geographical region? Because at the far side, on the right side where the customer connects, we there add information to help assess the locality of such prefixes. One might wonder, how do you figure out which communities to assign on the customer inbound routing policy? And for that, I wrote a small Python script that will calculate for you what these values should be so they can match further on in the network. In this Python script, I define the small database that we had at the beginning of the presentation, where we assign integers to routers and the GPS coordinates. And then the Python script will iterate through every possible permutation that could exist and figure out which sets of BGP communities you need to accomplish the goal of discarding outside a 1,000-kilometer radius. If you run the script, it will generate this for you and take care of which communities you need exactly to match, say, 2,500 kilometers. This works because we assigned all routers a country ID, a metro ID, and a continent ID. And if you piece those together, it kind of groups routers into areas. So you can view this as a Venn diagram, where if you need blackholing outside a 1,000-kilometer radius, then you need to match certain groups of routers to accomplish that. The only way to do this in a manageable way is you have to automate this. You cannot calculate this manually and configure your routers accordingly. Without automation, this style of service is a no-go. And you need to update your devices every time you add a new POP or a new market, something that changes the geographical reach of your network. That would be a good time to run that Python script and recalculate the required BGP communities for distance-based selective blackholing. As a customer, if you want to use this service, there is one very important aspect that is easy to oversee. You are used to generating a black hole route and announcing that to your service provider by blackholing it in your own network and using that generated route to have it propagate to your service provider. But with selective blackholing, that is precisely what you do not want to accomplish, because you want the route, the prefix, to remain reachable within a certain region and not outside that region. So that means you should not blackhole the prefix yourself in your own network in that region, because otherwise the concept is useless. So do something like a route that you generate, but don't install it in your forwarding base. Just have it propagate to the service provider, who will also not install it in the forwarding base within the region, but outside the region set a discard hub. As I stressed before, selective blackholing is only doable if you have 100% automation of your routing policies. You should have some CMDB where you assign integers to routers that represent their geographical properties, city, country, continent, and the GPS coordinates. Selective blackholing might be tricky to wrap your head around, but I think it's a very valuable tool to control the damage that DDoS attacks bring to you or your customers. And it's interesting because there's only a very small difference between all the routers. As I said, IBGP policy is something you would copy-paste from router to router, but it's only the community listings that are different from router to router. And as I mentioned, you can deploy this on any vendor. At NTT, we deploy this on Compass, Juniper, Cisco, both iOS and XR. You can do this on any piece that has route map capability. Your customers might not have asked for this feature, and I attribute that to that they might not even know this is possible. So lack of customer demand is not an excuse not to deploy this, I think. And realize that this saves both the service provider and the customer a ton of money. It is ideal if customers signal to me that they do not wish to receive packets coming from Asia to the port in Europe. That saves me transporting that DDoS over my backbone, and then when it arrives in Amsterdam, I drop it to the floor because the port maybe is congested. That no longer is the case with selective blackhauling. So both for service provider and customer, this saves you on transporting DDoS traffic on your backbone. So it's a win-win. This kind of concludes my presentation. At NTT, we will implement features like this this month. So you cannot use it today, but please check our website in, say, 2 weeks, and then you can start using selective blackhauling. And I'd also like to extend some thanks to friends that helped me. Peter van Dijk helped me write the Python code. Torsten Bloem and Saku Itzi inspired me to create this selective blackhauling concept. Are there questions? So either I delivered the information really well, or it just everybody is zoning out and waiting for the break to start. Has to be at least one question.
Sean Kennedy, EXO. So when you have a customer that sets this country, and let's say you peer with another network that's multinational, multi-continent at AMSIC, so they want to let it work within the Netherlands, but you then peer in the Netherlands with other carriers. What happens in that case for the customer?
Let me pull up this image. The whole selective blackhauling concept relies on the fact that everybody uses hot potato routing. So if you peer with a multinational network, you most likely peer with them in multiple regions. So for instance, between XO and NTT, if a Dutch NTT customer wants to discard packets outside the Netherlands, XO will hand over packets that come from XO's American customers in the United States, but NTT routers will discard there. However, XO's Dutch customers, they will hand over the packets over a Dutch interconnect, and that will forward the traffic because it's within that region. So this works because networks peer with each other in multiple regions, and because we use hot potato. God bless hot potato. Does this answer your question? Any more takers? If at some later point you have questions or are trying to implement this in your network, just send me an email and I'll be happy to help you out and figure out how you can do this.